So to start, we'd take a look at this one. Kind of an odd looking question. If y is equal to 2u cubed plus 3u squared, so this is y as a function of u, and then u is equal to x plus 1 over x, we want to get the derivative of y with respect to the x variable. So now, I would first off take this u function and express it in slightly different terms. I would write this as x plus x to the negative 1. For sure, when we differentiate it, we will want to have it in that form. Now, I'm going to do this one first off long method. I'm calling it the long method, but it's more like the breakdown method. So occasionally this will take longer. But this can be a little tricky otherwise, because really what you've got is y in terms of u, and then the u variable in terms of x. So I mean, you could just take everywhere you saw a u, you could replace the x in there and then differentiate it like that. But these next two questions are examples where you're actually better off, I think, in breaking it down and then reinserting it again. Now, dy dx, which is what we ultimately want, is equal to the derivative of y with respect to u multiplied by the derivative of u with respect to x. That is the chain rule. So it means that if all we really need to do is get each of those and then put them or multiply them together again. So dy du would be equal to 6u squared plus 6u. And then the derivative of u with respect to x, that is a u there, not a whatever, is equal to 1 minus x to the negative 2. So that's du dx. And the next step would be plug her back in. So dy dx is equal to dy du, which is 6u squared plus 6u multiplied by du dx, which is 1 minus x to the negative 2. Now, we need to go further because we currently have it in terms of, or we have a u variable kicking around when we want to have it in terms of x. So we replace the u with what it's equal to in x, so that would be x plus 1 over x squared plus 6 times x plus 1 over x, and this would be multiplied by 1 minus x to the negative 2. I'll write that as 1 over x squared. So that's the method for it. Was it easier? Well, perhaps. But for sure, when they get really complicated, like the next one, you are advised to do it this way. So the next one looks like this. Given y in terms of u, u in terms of v, and v in terms of x. And we want dy dx. So the chain rule, once again, will tell us that when we have functions nested inside another function like this, dy dx would be equal to the derivative of y with respect to u multiplied by the derivative of u with respect to v multiplied by the derivative of v with respect to x. Now, those are not quotients. It's important to remember that dy du is a single term, meaning the derivative of y with respect to u. It's not dy divided by du. Nevertheless, it does tell you whether you've got the setup right, because if you did think privately to yourself that you're canceling out du's and dv's, you would be left with dy dx. So I'm doing that. I'm not writing it. I don't want there to be any evidence of that. And now I go after each of those three. So dy du is equal to 1 over 6 times 3, which is 3 over 6, so that's 1/2 u squared. And then du dv is equal to, well, 16 goes away, but 2v or v squared become 2v1. And then this one I would also write in a different form. I would write this as 2 over x to the 1/2, which becomes x to the negative 1/2. So dv dx will be equal to negative 2 times negative 1/2 is 1, and then x to the negative, which is good, and then this becomes positive 1, and then subtract 1 from the exponent gives you negative 3 over 2. So now in it goes right back to the chain rule proper. So dy du is 1/2 u squared times du dv, which is 2v, times x to the negative 3 over 2. Now the 2's will divide out. That's good. But now we still need to make the replacement. dy dx will be equal to u squared, and that's going to be 16 plus v squared all to the 2, multiplied by v, which is 1 minus 2 over root x, and then times x to the negative 3 over 2. And you could have done this in one step, of course, will see that the v needs to be replaced in terms of x. So dy dx is equal to 16 plus v, which is 1 minus 2 over root x squared, and then all of this to the exponent of 2, multiplied by 1 minus 2 over root x, and then all this times x to the negative 3/2. Now if I was doing this whole thing again, I'd probably have that to the front, and you could bring it to the bottom with the negative exponent. The one thing that's a little bit awkward with this one is because we already have some denominators in the earlier part of this expression, and I'm not going to write it as a complex fraction, so I'll keep it like this, which is, it's not pretty, but it is all there. So that is the chain rule proper. The earlier examples were more important, I suppose, in terms of simplification of these. But now we have enough tools that we can pretty much tackle every sort of function that we run into. Thank you for your time.